Let's continue our session with spool operations in SQL Server. Spool operators are often used in execution plans and can significantly impact query performance. Therefore, learning these operators are very much important if you want to effectively troubleshoot slow queries or fine-tune queries. Let's start with physical operator functions first. Whenever physical operators such as compute scalar starts, three things happen. First, init method is invoked. For example, physical operator is initialized and structures are set up. Then GetRow method is run to get the required rows from the next operator. Okay. GetNext method or many GetNext calls are run after GetRow to get remaining rows if there are many rows. Third, once the operator is done performing its functions and getting all the required rows, it needs to clean itself and shut down, which we call close method. A rebind and a rewind both count the number of times the init method is called by an operator. We should always remember one thing. Rebinds and rewinds are only relevant and the property value is only populated when the nested loops operator interacts with one of the following operators. Each of these operators can save the results from its previous execution. Let me explain how this works in this way. For example, you saw these operators in execution plan. Let's see how this operation is done in the background with rebinds and rewinds. Suppose we have this corresponding sample table and a nested loop operation. For clustered index scan operator, rebind and rewind is 0 because, as I mentioned before, rebind and rewind is calculated only for these operators and become relevant. What about index spool? Let's see how it is calculated. When nested loop is initialized, it also initializes index scan operator. Then index scan operator starts to pass the row to nested loop operator. After getting the row, index spool operator is initialized and this value is compared with each value in this spool table. When it first initialized, rebind goes up by 1. Okay? If there is a matching value, nested loop passes this value to next operator. If there is not, this value is omitted. After checking first row, nested loop starts running GetNext function and get all the rows one by one and repeats the same process with index spool. Every time the value is repeated, SQL Server does not repeat the process. Instead, it just rewinds it. If the value changes, it rebinds it. Let's see this in a real example. By running this command, I create a random sample table. Then, let's run this. As you can see here, rebinds is 600, which means all the values from the index scan operator are unique, okay, non-repeatable, and we don't have rewinds for this. So let's go back to spool. So what is spool? Firstly, spools read data from child operator and store it in work table. Secondly, the data is saved in buffer pool in memory along with other data. Therefore, there is no need for extra separate memory. When there is memory pressure and buffer pool contention happens, data might be saved in disk and read from disk might be causing performance issues. There are 4 types of spools: table spool, index spool, row count spool, window spool. Since table spools are often observed, we will concentrate on the spools in this section. So let me show you an example. Let's run this query. Here we can see eager spool table spool, which is being generated from child operator index seek. Afterwards, saving all the needed data, table spool is passing the data to next parent compute scalar operator. In the end, data is being changed. If I explain this in another way, for example, with index seek, target rows are being found. Afterwards, all these target rows are saved to table spool. Important point here is SQL Server waits until all the target rows are saved in table spool. Therefore, we call this type as eager spool, which is blocking mode operator. Okay, we cannot move forward until this eager spool saves all the data. After getting all the rows, table spool passes each row one by one to next parent compute scalar operators, where scalar operations are made. Let's see other type of spools. We run this query. Here we can see two different scenarios. One is lazy spool, and another one, interestingly, there is no child operator for this spool. Where this spool is being generated from? Let me explain. Firstly, upper part is being executed by doing index scan. We are bringing the rows, right? After that, sort operation is happening. After sorting, SQL Server is creating segment by grouping by client. Finally, table spool is being created. Then, by using this same table spool, we carry out bottom part of the execution plan. This shows that one table spool can be used several times in different locations of the execution plan. Great, isn't it? After that, for each segment, we'll calculate sum and count. Then, we'll calculate average. And again, using the same table spool a third time, we do nested loop operation by comparing each value to average and bringing the value lower than the average value for each segment. Finally, we do last nested loop join operation. So, this is a flow. Now, here you can see lazy loop. What does this mean? This means that this is a stream operator, not blocking operator. We don't need to wait until all the data to be gathered. For example, since the data is sorted when segment A data is gathered, we can continue operation with segment A first and submit the result to the client. We don't need to wait until all the segment data is gathered. Something like this. If you want to confirm this flow, you can check properties of the operators. For example, here, first we are bringing 600 rows based on the index scan. Afterwards, we are doing sort operation. Then, you can see here, based on client column, we are grouping by and creating segment. This segment is outputting 3 columns, client, valor, and segment. Finally, we are creating table spool. After that, by using the same spool, we are doing stream aggregate. You can confirm node ID here. Parent node ID is the same with the node ID of this operator, which means the same spool is being used and the spool is being generated here. Aggregate function can be confirmed here. We are calculating count and sum. As a result, sum and count columns are being output. Finally, we are calculating average by dividing sum by count. Then, we are doing nested loop join by using this predicate, which shows that we are comparing average column values for each segment. Finally, we are doing last nested loop join. You might also see index spools sometimes. Compared to table spools, index spools have an additional non-clustered index to make it easier to retrieve the data. Other features and use cases are nearly the same. Based on our observation, we can conclude use cases of spool. Spool is used first to ensure that original table copy is available for insert, update, and delete operations. Also, to make the same copy of data available for multiple branches of execution plan, spool is used. Finally, spool is also used to provide the copy of the data available without re-executing child operations. Happy learning!